In today's video, I would like to show you a little trick that might change your perception about spatial audio forever. What we're going to do is we're going to extend the idea of mid-side processing into three-dimensional space. And this is actually very easy to do, very straightforward and surprisingly effective, both for spatial audio applications, but also for stereo. It's actually one of those things where once you know how to do that, you try to figure out why nobody ever talked about that. In fact, I haven't seen anybody really mention this possibility, so I figured I need to do a video about it. And this is what we're going to do today. But first of all, hello everybody. In case you're new here, my name is Michael Wagner. I teach at the Antoinette Westphal College of Media Arts and Design at Drexel University in Philadelphia. And on this channel, I talk about digital media, game design, and spatial audio. And if any of those topics interest you, I invite you to subscribe or join my Discord community. That link is in the description below. And since you're already at it, also please don't forget to press the like button, especially if you get any value out of my videos. It really helps out the channel and makes my videos more visible to other people. Thank you. Before I can get into the details about what we're going to do today, there are two concepts that I need to clarify. The first one is mid-side processing. Now, if you have spent any time in audio production, you're most likely aware about mid-side audio processing. It essentially refers to the idea that instead of processing the stereo version of your audio, what you're doing is you're converting that into a two-channel format where one channel represents the mid information of your signal and the second channel represents the side information of your audio. And that has a couple of really interesting applications. For one, what you can do is by increasing the level of the side channel, you can essentially widen the image of your stereo audio. Or another very important application is that in mastering, for example, that you can cut off the lower frequencies at the side information because that kind of feels weird and that kind of cleans up the low end in your final production. Now, this is something that has become very, very popular, and it's now not only used for these two types of applications. You can actually see mid-side processing in pretty much anything, in distortion plugins, in compressor plugins, in limiter plugins, you name it, there's probably a mid-side processing version of that particular plugin. So what we want to do today is we want to extend that mid-side processing idea into three-dimensional space. And the way to do that is by using our second concept that I need to talk about briefly, which is ambisonics. Now, I'm not going to spend too much time explaining what exactly ambisonics is. If you've never heard about ambisonics, I invite you to watch one of my previous videos where I go over all the details of ambisonics, and also a video where I kind of explain the differences between ambisonics and Dolby Atmos, for example. I'm going to post a couple of links in the description below. But I need to kind of just touch a couple of key points that we need in order to understand how we are going to use ambisonics to extend the mid-side processing paradigm. When people introduce ambisonics, they usually use the concept of virtual microphones. And the virtual microphones have pickup patterns like the ones that you see here on the side. And the idea is that you're capturing a three-dimensional sound environment with these virtual microphones. So in this particular case, this would be the virtual microphones of a third-order ambisonic signal. And the idea is that each channel in the ambisonic signal is captured by one of those virtual microphones. And these are then kind of ordered in a certain way. And this is called the ambisonics order. So at order 0, for example, you just have the one idealized omnidirectional microphone. At order 1, you have 3 additional virtual microphones. And at order 2, you have 5 additional ones. And at order 3, you have 7 additional ones, and you can actually go up to higher orders, but usually kind of you stop at order number 3. Now, there are really only two things that we need to know in order to understand the little trick that we're going to use today. And the first thing is that in an ambisonic signal, the very first channel, which sort of represents the ambisonic signal with order 0, the very first channel is the mono signal. That is essentially the type of signal that you're getting if you're using an idealized omnidirectional microphone and essentially capturing audio that way. So it's essentially the mono information. The second thing that we need to know is that the second channel in an ambisonic signal is essentially the traditional side information of a stereo signal. That is because of the way this virtual microphone works, and I kind of alluded on that in one of my previous videos. Once again, link in the description below. But that is actually quite interesting, and not a lot of people actually take advantage of that, because in an ambisonic signal, once again, the first two channels are really mid and side information. Now, they are technically not exactly mid and side information. There's also a scaling factor in there somewhere, but essentially they are kind of representing the same type of signal, and if you scale one of them up, then essentially you get exactly the mid-side information. information. Now, the interesting thing about ambisonics is that the third and fourth channel are essentially just side channels for the two other dimensions, really. So the third channel is really the side information for the vertical direction, and the fourth channel is the side channel for the depth direction. So in a first order ambisonic signal, the first channel is sort of the mid channel, and the three remaining channels are the three dimensions of the side channel, and we can use them in exactly the same way we would use a regular mid-side a signal, and can do all kinds of things with it. And this is what we're going to do today. So let's get started. The project that I'm going to use today in order to demonstrate this approach to mid-side processing is a very simple Cubase project. I am working on a Mac today, but once again, doesn't make any difference if you're on Windows or Mac. And it also, quite frankly, doesn't make any difference which DAW you're using. As long as it's a DAW that can handle ambisonics audio, you should be fine. So let's just have a brief listen on how that loop sounds. So it's essentially a very simple MIDI loop put on a track that has an instance of tune. And what I'm doing is I'm taking that stereo signal, I'm converting that into a third order ambisonic signal by kind of routing it into the ambisonics track here. And the only thing that I did on the ambisonics track is that I changed the decoder that is used. So instead of using the standard decoder that comes with Cubase, I essentially switched that to the Audio Brewer's decoder because I really like that. And the second reason really is that because it's really kind of nice, has a nice visualization. So anything that I'm going to kind of show you today becomes very, very clear once we look at that particular decoder. I've switched that decoder to third order ambisonics in order to make sure that it is actually decoding a third order ambisonic signal. And I've also switched that to headphone mode. So if you are watching this video, you will get the best impression if you're listening on headphones. So what I really want to do is I want to control the side channels individually from the mid channel. And that essentially means that I need to be able to control the channels individually. Now, unfortunately, I can't do that directly in Cubase. So what I'm going to do is I'm going to use a tool that is called Block Bidule that will allow me to add additional functionality to individual channels within my ambisonic signal. Now, if you're working with spatial audio, you most likely already have your Block Bidule. If you don't have Block Bidule, there's an alternative way you can do that with a tool that's called Cush View Element. I'm going to post links in the description below, but Cush View Element is essentially free. So if you want to just kind of try it out and play around with it, just kind of work with Cush View and with Element, and it essentially kind of should work just in exactly the same way. But I'm going to work with Block Bidule. So let's just open our ambisonics channel and let's add an instance of Bidule. Now, this is a 16 channel track, so I need to add an instance of the 16 channel version of Block Bidule. So let's open that up. And as soon as I have that, I'm getting the Block Bidule here. Now, I'm not really interested in the mixer here, so let's just delete the mixer here. What I really want is I want to have individual volume control over all the side channels or the individual channels in the ambisonic signal. So what I'm going to do is I'm going to add an instance of the multi-gain tool. And we once again have 16 channels. So let's just open up the multi-gain 16, and this will then kind of add that. And the final thing that I need to do is I need to connect the input with the tool, and then essentially the same thing here. And that should now kind of move all 16 channels from the input of Block Bidule into the output of Block Bidule. So let's just double check if everything is sounding correctly. And indeed it does. So let's get into some manipulation. So the first thing I'm going to do is I'm going to open up this multi-gain tool. And for the moment, I'm going to disable the higher orders of the ambisonic signal. I'm just going to be interested in the first 4 channels, which essentially, once again, is the first order ambisonics channel. So let's just mute the 7 channels that belong to the third order. I'm going to come back to them later. So let's just mute those. Those are 1, 2, 3, 4, 5, 6, 7. And then the 5 channels that are representing the second order. And we're just left with those 4. And in order to make sure that everything is also working correctly, let me just open up the decoder, because what we want to do is we want to actually now decode not a third order ambisonic signal. We just have the first order ambisonics. So let's just switch the decoder to first order ambisonics to make sure that it's also decoding everything correctly. So let's just play our audio and let's get a little bit creative with our 4 channels that we have here. So what we essentially see is that we have these 4 channels now, and once again the first channel is the mono signal. So if I'm muting the 3 side channels, I'm essentially getting a mono signal, right? Now if I'm unmuting the second channel, I have the stereo signal back, because once again this is just the mid-side information. So if I'm now increasing the second channel here, I will actually increase the spatial nature. I will actually kind of make the audio impression wider. So let me just kind of increase the signal here and maybe decrease the mono signal. So this will essentially make the impression wider. Now I can do the same thing also for the other channels. So let's just open up or unmute these channels. Now, let me just stop that for a second. Now, you see that essentially because of the way the audio is currently positioned as something that is right in front of me, slightly above me, but it is a stereo signal, so it is essentially on a horizontal line. So you can think of it as being on a horizontal line. If I'm now kind of changing the side channel of the vertical information, for example, what it will do is it will expand the space into the vertical direction. So what this essentially means is that the signal should actually move upwards. So let's just see if that is actually what's happening here. So let's play that again. So if I'm now increasing the second or the third channel here, what it will do is it will once again expand the vertical direction. So this position here should actually move upwards. So let's see if that's actually happening. And indeed it is. So essentially we have now distorted the 3-dimensional space somewhat into the upwards direction. And we can do the same thing with the depth direction. So if I'm now kind of increasing the signal into the depth direction, or if I'm increasing the side information of the depth, I should actually kind of move that back down again, because now I'm also increasing the kind of the space in the depth direction. So let's just do that as well. And it's once again moving backwards. So what we can do now is we can use this effect in order to get creative. We can do all kinds of things. We not only limit it to changing the amount of gain that we have on the individual channels. What we can do is we can also, for example, apply an EQ, or we can apply a compressor or a limiter or even a distortion on one of our side channels or multiple side channels or on the mono channel. Whatever kind of floats your boat, you can do now. There's no limits to this. Now, one thing I need to mention is that I think one of the reasons nobody has really kind of thought about that yet is simply because in a traditional, in the traditional way you would normally use ambisonics is something that you use in order to capture 3-dimensional sound. So usually kind of you have an ambisonics microphone, you go out and then you capture your soundscape. And the idea of actually creatively changing the 3-dimensionality of that sound, or kind of how that sounds isn't really something that people would normally think about when they are working with ambisonics. So the traditional way of approaching ambisonics is really as something that represents kind of a real life recording, and you wouldn't really kind of use that recording creatively. However, with the current push into the direction of spatial audio, more and more people are really interested in kind of using these things creatively, and there's absolutely no reason why you couldn't do it that way. So essentially just kind of play around with those channels and do whatever you want with them, and it actually gives you something that might be useful or might not be useful. Whatever floats your boat, do it. So let's look at an example, and what I want to do is I want to simply kind of use an EQ on the individual side channels, and I'm not going to do that in a way that I'm not going to kind of use an EQ individually for each of the 3 side channels. I'm actually going to use one EQ for all side channels simultaneously, and I'm also going to look a little bit in what we can do with the second and third order channels of the ambisonic signals. So for this purpose, I've reset everything, so the gain is now once again back to where it's supposed to be. So we now have a regular first order ambisonic signal that we are passing through. And what I want to do is I want to add an EQ. Now for this purpose, what I'm going to do is I'm going to add instances of ProQ, FiveFilter ProQ. Not a lot of people know, but ProQ, all the FiveFilter plugins actually are capable of handling multi-channel audio. So we're going to add instances of ProQ into our ProQ setup. Now, in order to do that, once again, we go into the music effects, and here we have under FiveFilter ProQ. And if you have ProQ, you essentially can select how many ins and how many outs you want. Now, I want to control the levels or the layers of the ambisonic signal individually. So essentially, one EQ for the mono signal, one EQ for the side channels, one EQ for the second order channels, and one EQ for the third order channels. So I essentially need 4 instances of ProQ in our setup. Now, since this is a little bit fiddly, what I'm going to do is I'm simply going to add that now, and I'm going to see you in a second after I've added everything. Okay, now I'm back. I added 4 instances of ProQ. Once again, one instance that is responsible for the mono channel, the second instance that is responsible for the 3 side channels, the third instance that is responsible for the second order channels, and the fourth instance that is responsible for the third order channels. Now at the moment I've still muted second and third order channels, so I still only working with first order ambisonics, as we see here in the decoder. And let's start by doing the obvious thing. And the obvious thing would be to essentially just put a high pass filter on the side channel. So let's just do that. So let's open up ProQ and let's play our little loop once again. Now this doesn't really have a lot of low end information. So what I'm going to do is really a little bit more kind of just to show what you can do. So let's add that here, and let's add a high pass filter. And that will essentially push the higher frequencies to the sides in all 3 directions, not only in one, but actually in all 3 directions. And let's maybe do the other obvious thing, or kind of just as a contrast to that, let's just kind of reduce the higher frequencies on the mid channel. So let's just maybe add another low pass filter here. So now I have the lower frequencies in the mid channel, and I have the higher frequencies on the side. I can obviously also change the gain. So let me just kind of bring that gain down a little maybe. And by contrast, maybe let's have the other one a little bit up. And obviously you can do all kinds of things with that. So you can once again do a compressor, you can do a whatever floats your boat. You can work with that. Now obviously we can actually go one step further here because we also have second and third. Let me just stop there for a second. We also have second and third order information here, and we can work with those as well. Now second and third order information will be a lot more subtle. So this is probably not something that you might use often, but you could if you want to. And if you look at the virtual microphones in the setup that I showed you earlier, you might have noticed that the second order information is primarily responsible for the information into the direction of the edges of the cube. So if you think about kind of the 3-dimensional space that you're in as a cube that is essentially kind of in the 3 dimensions, then essentially the second order channels really kind of point, or the virtual microphones of the second order channels really kind of point towards the edges of that cube. And in the third order information, you have the information that points towards the vertices of this cube. So kind of you might kind of start kind of looking into what these channels are actually doing and find some way to creatively use them. But my feeling is that most of the use cases probably are very subtle, and you might not actually kind of really use them that much. But nevertheless, let's just see what we can do. So let's open up the 5 channels that make up the second order information. So we have 1, 2, 3, 4, 5. That means that the remaining 7, which are the third order information, are still muted. Let's switch the decoder to second order information, and let's open up Pro EQ. And let's maybe play our sound again. Now one thing that we could do for an example, and once again, I'm just kind of doing stuff in order to show what you can actually kind of accomplish. So what we can do, for example, is we can, in order to counter the fact that we have cut out the higher frequencies in the first order and the lower frequencies, or the other way around, the lower frequencies in the first order and the high frequencies in the mono signal, maybe just kind of cut out the one in the middle for the second signal. And let's maybe, and as you can already hear, this is a lot more subtle. Reduce the signal a little. And since we already added, also bring in this third order ambisonic signal. So let's unmute these. And let's switch the decoder to third order ambisonics. And let's maybe reduce the gain on this one, and let's just leave it. And that's how you can play around with the individual channels of the ambisonic signal. So as you can see, this is really simple to do. It's very creative and has a lot of completely unexplored potential because, quite frankly, nobody talked about that yet. And that, to me at least, is really surprising. Now, if you are an audio producer working in 3D audio, I would really like to hear from you if this is something that you find interesting, if this is something that you could see yourself using in your productions. If you're using it, if you're playing around with it, I would also like to hear about any applications that you're using it for. What are the things that this approach is really useful for? It's not only obviously kind of just widening the 3D image. There might be all kinds of things that you can do with this particular type of approach. And if you're a plugin developer, I would like to hear from you as well. If you have any plugins that you think would actually work well with this particular approach. Many plugins have mid-side processing included. Why not also include this extended version of mid-side processing, especially for plugins that are meant to be used in a multi-channel setup? So if you have any questions, comments, suggestions, whatever, please use the comment section below or join my Discord community. And with that being said, see you at the next video.